Innovation and technology has been required to enable exploration and pioneering throughout the history of the human race. And there are challenges cast in three different categories. Our challenges is we have to get there, we have to land there, and we have to live there. There's a large logistical challenge in staging the systems we need in orbit that makes sense, and then getting those systems to where we're going, Mars, and then crew transport, and all the logistics that goes around that. And so you'll see in situ resource utilization, or living off the land, we can get a huge benefit and a large gear ratio with respect to architectures and affordability and reliability if we can do as much living off the land as we can do. We have a challenge out there right now called the 3D Printed Habitat Challenge, which is looking at producing components and assembling them into a structure, a habitat, using Martian regolith, or dirt, soil, and waste, garbage, plastics. We use the International Space Station as a test bed for technologies. We've had multiple robotics technologies, a technology called Sextant that's using pulsars for precision navigation that's going on the station, et cetera. We'll continue to do that for the life of the station. We're developing with JPL the Deep Space Atomic Clock for precision navigation in space and other uses. Our first mission kind of beyond low Earth orbit is the Asteroid Redirect Robotic Mission, which is part of ARM, the Asteroid Redirect Mission. So high power solar electric propulsion, done a lot of work there in recent years, building on previous work. So Hall effect thrusters with magnetic shielding to improve lifetime and reliability. Also, we've developed with two companies a large area deployable solar arrays to provide the energy and the power for the high power solar electric propulsion. Lots of work in interest-sent landing technology. So MSL Curiosity landed about 1 metric ton to the surface of Mars. But we're at the limit of what we can do with that architecture. 1 metric ton is it. It doesn't scale higher. And if you look at the architectures that we're looking at for human exploration, we could be talking about 23 metric tons to the surface, 28, or even up to 40, and that's driven by the descent vehicle, the vehicle to get crew off the surface. And so we're looking at a suite of technologies, supersonic vertical propulsion, and also advanced chutes and inflatables. Looking at inflatables and deployables for hypersonic aerodynamic deceleration, HIAD and ADEPT. We developed a woven thermal protection system, Ames did. We have a very robust small spacecraft technology program, and we have 4 missions coming up, going to demonstrate some really interesting technologies in the next 6 to 9 months. And then we had our second flight of both the inflatable decelerator and the parachute, maybe something for a Mars sample return type ascent vehicle.